Nobody handed me this story. I found it the way you find most things that matter, by accident, then obsession. It started with a photograph, not a famous one, not something you'd find in a textbook or a museum archive. A single image, poorly scanned, uploaded to an obscure forum thread that had gone dead years before I stumbled onto it. The photograph showed a street, somewhere in Central Asia, based on the architecture, dated, according to the handwritten notation on the reverse, to somewhere in the 1870s. I almost scrolled past it. But something made me stop, something in the geometry of the buildings, the way the facades were arranged, the proportions that didn't match anything I'd been taught to expect from that region, that period, that supposed level of development. I saved the image, enlarged it, printed it out and pinned it to the wall above my desk. That was 3 years ago. Since then I've spent hundreds of hours in digital archives, physical libraries, engineering records, cadastral surveys, missionary journals, trade ledgers, and construction permits spanning 4 continents and 8 decades. I've corresponded with architects, historians, structural engineers, and a retired canal surveyor in Belgium, who may be the only living person with direct professional knowledge of a specific class of 19th century lock mechanism that appears in 6 different countries with no documented point of origin. What I've found doesn't fit the story we've been told. Not slightly, not in minor details that can be smoothed over with footnotes. Fundamentally, structurally, in ways that, once you see them clearly, make the official narrative not just incomplete but actively impossible. This is what I found. This is what life actually looked like before everything changed. Let me start with what we are supposed to believe. The standard account of the world before the 20th century is, if you reduce it to its essentials, a story about limitation. People were limited by technology, by communication, by transportation, by knowledge. Cities grew slowly. Trade moved at the speed of a horse. Information traveled at the speed of a letter. Construction required decades of manual labor. Sophistication in every domain was a luxury of the very few, and even then it was modest by our standards. This is the world we've inherited in our imagination, the world of mud and candlelight, of merchants who couldn't reliably know the price of grain 3 cities away, of builders who couldn't guarantee their walls would stand for more than a generation, of populations who rarely traveled more than 20 miles from where they were born. Now go look at what actually remains. Walk through the old quarter of any major city on 3 continents, Istanbul, Lahore, St. Petersburg, Cairo, Mexico City, and count the buildings constructed before 1880 that are still standing, still functional, still structurally sound. Then count the buildings constructed between 1960 and 1980 in the same cities that are crumbling, patched, leaking, retrofitted with external supports they weren't designed to carry. Which civilization built for permanence? Which civilization built for fragility? The question answers itself the moment you ask it honestly. Begin at the beginning. Begin with where people actually lived. Residential buildings from the period, we're told, was primitive show engineering characteristics that have no explanation within the official timeline. Foundations sunk to depths that modern soil engineers would recognize as appropriate for seismic zones, in cities where nobody was supposed to understand seismic activity. Load-bearing walls with material compositions that laboratories, when they've bothered to analyze samples, identify as chemically superior to contemporary equivalents. Lime mortars with additive profiles suggesting deliberate formulation, not accidental mixing. And the spaces themselves, the ceiling heights alone demand explanation. A standard residential room in a mid-19th century apartment building in any of a dozen cities runs between 12 and 16 feet floor to ceiling. We are told this was decorative, a status display, the architectural preference of an era that hadn't yet learned efficiency. But think about that explanation for a moment and notice how quickly it collapses. Heating a 16-foot ceiling costs approximately 4 times what it costs to heat an 8-foot ceiling, given equivalent insulation and equivalent fuel. These were not wealthy households. These were not aristocratic townhouses. These were the residences of merchants, craftspeople, minor functionaries, the emerging professional class, people who made calculated decisions about money constantly. Nobody heats 16-foot ceilings unnecessarily. So ask the question the official account never asks. What were those ceiling heights for? What function did that volume serve? Because it served something. You don't build what you don't need when every cubic foot of construction represents labor, material, cost, and time. The people who built those spaces weren't foolish. They weren't wasteful. They were solving a problem we no longer recognize. Ventilation is one answer. Not simple air circulation, but managed atmospheric flow. buildings designed to create pressure differentials between floors, drawing contaminated air upward and out through specifically positioned apertures in the upper walls. Look at those buildings closely enough and you find the apertures, positioned with geometric regularity. Not random vents cut for convenience, but deliberate openings calculated for airflow dynamics that modern HVAC engineers would recognize immediately. Light distribution is another. The window proportions in these buildings, the height relative to the width, the placement relative to the room's geometry, when you model them computationally, as some researchers quietly have, they maximize natural illumination across the entire floor area throughout the entire solar day at the specific latitude of the building's construction. Not approximately, not adequately, precisely. Somebody calculated those windows. Somebody who understood solar angles, seasonal variation, and interior light distribution, with a sophistication that implies either extraordinary empirical knowledge, accumulated over generations, or something else entirely, access to a body of architectural science we've decided to attribute to the 20th century. The ornamental plasterwork is where conventional historians stop engaging entirely. Because once you map the geometric patterns that appear in the crown moldings, ceiling medallions, and wall friezes of 19th century residential buildings across multiple continents, and once you measure the mathematical relationships between the repeating elements, the ratios, the progressions, the symmetrical structures, what emerges is not decoration. What emerges is encoding. The same ratios appear in buildings in Kazan and Colombo, in Odessa and Cartagena, in Riga and Rangoon. Not similar ratios, not approximate aesthetic parallels that you might attribute to shared cultural influence. The same ratios, measurably, verifiably identical. Buildings that had no documented contact with each other, built in periods when communication across those distances was supposed to be primitive and slow, expressing mathematical relationships with precision that argues for a common source. A common source of architectural knowledge that official history cannot name. Step outside into the street, because the streets themselves are part of the evidence. Look at the grade of a 19th century urban thoroughfare in any city that hasn't been completely rebuilt. The slope is consistent. The camber, the subtle curve across the road's width that directs water to the drainage channels at the edges, is engineered, not accidental. The drainage channels themselves connect, through a system of buried pipes, to a network that extends beneath the entire district. A network that, where it hasn't been deliberately interrupted, still functions today. We excavate sections of these systems during infrastructure upgrades, and what we find consistently surprises the engineers on site. Pipe diameters standardized across networks that were supposedly built by independent municipal contractors working without coordination. Jointing techniques that require specific tool profiles, tools that appear identically in photographs from 5 different countries, held by workers who could never have met. Gradient calculations that, when surveyed properly, reveal awareness of subsurface geological features that the official record insists weren't mapped until decades later. How do you survey what you don't know exists? How do you engineer around geological features you haven't discovered? The silence in the documentation is not the silence of incomplete records. It's the silence of records that were never created. Because what was known didn't need to be written down, because it was already known, already understood, already part of an inherited body of technical knowledge that predates the documentary record we've been given access to. The street layouts themselves encode this knowledge visibly enough that satellite imagery now makes it undeniable. Go look at the oldest cores of cities across Eurasia and North Africa from above. The geometric precision of the major avenue alignments, the radial patterns that organize districts into sectors with mathematical regularity. The orientations that correspond not to arbitrary historical accident, but to cardinal directions, solar alignments, and topographic features mapped with survey precision. These layouts required aerial perspective or extraordinary ground-based triangulation. Neither should have been available. Both were clearly used. Now move beyond the cities, because life in this period wasn't confined to urban centers. The majority of the population moved, not chaotically, not randomly, through systems. And those systems are where the story becomes most impossible to explain away. The overland trade routes we've inherited as romantic images of wandering caravans were in operational reality, managed logistics corridors of extraordinary sophistication. Take the network connecting the major commercial centers of Central Asia, the routes that Russian imperial administrators encountered when their expansion brought them into contact with pre-existing infrastructure they hadn't built and couldn't fully explain. The way stations positioned along these routes appear at intervals that correspond not to days' ride estimates, but to precise calculations of loaded draft animal endurance under specific conditions of terrain and elevation. The calculations require knowledge of animal physiology, gradient measurement, load optimization, and climate data across thousands of miles of varying territory. They require, in short, systematic knowledge, assembled over time, and distributed to route planners who operated according to standardized specifications. Inside the way stations, the evidence deepens. Construction techniques identical across facilities separated by 1,000 miles and 3 mountain ranges. Storage systems designed for specific commodity preservation. Grain separated from oil separated from textile goods by material-specific humidity and temperature management. Water systems drawing from geological sources, identified with hydrogeological knowledge that implies survey methodologies we've assigned to the late 19th century at the earliest. And the goods that moved through these systems. Port records where they survive intact and haven't been edited or summarized by later archivists with agendas, show commodity flows of staggering volume and bewildering geographic range. Ceramics from specific production centers appearing in markets across 3 continents within timeframes that, when you calculate backward through known transportation speeds, require either impossible movement rates or distribution networks operating simultaneously from multiple production points simultaneously. Standardized production, standardized distribution, standardized pricing, because the records show price coordination across markets separated by distances that supposedly made real-time communication impossible. How do you coordinate prices without communication? The answer that conventional history offers, slow diffusion through traveling merchants, gradual market equilibration over seasons and years, fails on contact with the actual numbers. The coordination is too tight. The synchronization is too precise. The response time between supply changes and price adjustments across distant markets is too fast. Something else was operating, some other mechanism of information transmission, and the records hint at it without ever naming it directly, the way records hint at things that the people writing them considered too obvious to explain. The water systems deserve their own examination because they represent, in many ways, the clearest evidence of what was known and how broadly that knowledge was distributed. By the middle of the 19th century, before the supposed maturation of civil engineering as a formal discipline, before the establishment of professional credentialing bodies, before the publication of the theoretical hydraulics literature, we're told made modern water management possible. Cities on 4 continents were operating pressurized water distribution networks of operational sophistication that modern utility engineers, when they're being honest, describe as remarkable. Remarkable isn't the right word, impossible is closer. The reservoir systems required geological site selection, identifying subsurface geology capable of holding water without significant loss to permeation, positioning catchments to exploit natural watershed dynamics, calculating storage capacity against seasonal demand variation across multi-year drought cycles. This is not empirical trial and error knowledge. This is systematic geological and hydrological science applied at scale. The distribution networks required hydraulic calculations, determining pipe diameters for specific flow rates at specific pressures across specific distances and elevations, managing pressure differentials to prevent pipe failure while maintaining delivery pressure at terminal points across the network. This requires mathematical modeling, not simple arithmetic, mathematical modeling of fluid dynamics under variable conditions. And the filtration systems. This is where the conventional account becomes completely untenable. Water filtration in the mid-19th century involved multi-stage processes, settlement, biological filtration through sand and gravel beds of specific compositions and specific depths, chemical treatment at the clarification stage that required knowledge of microbiology and chemistry that official history places firmly in the latter half of the 19th century. Except the systems predate the official knowledge by decades. Not approximately, not in isolated experimental cases, routinely, in cities across 3 continents, water treatment systems were operating on scientific principles that the academic literature supposedly hadn't yet articulated. The people operating those systems knew what they were doing. They knew why it worked. They had a theoretical understanding of the processes they were managing. We just can't find where they learned it. Because the documentation of the learning, the curriculum, the textbooks, the professional training programs doesn't exist. What exists are the systems themselves, operational and sophisticated, staffed by people who clearly understood them, with no traceable educational lineage. Knowledge doesn't appear without transmission. Skills don't emerge without training. understanding doesn't exist without somewhere it came from. The question isn't whether the knowledge existed. The water systems prove it did. The question is where it came from and why the transmission pathway is invisible. If this research matters to you, if these questions seem worth asking, consider subscribing or becoming a member. This investigation represents years of archive work, correspondence with specialists, and analysis of material that most researchers never examine. Your support makes it possible to keep going deeper. Inside the factories of this period, the anomalies multiply to the point where the conventional narrative requires you to simply stop looking at the evidence. Photographs survive of manufacturing facilities from the 1840s and 1850s, textile mills, foundries, ceramics works, chemical plants, showing floor machinery of a scale and apparent precision that shouldn't exist. Not because precision manufacturing is surprising by that point. The history of precision metalworking has clear documented lineage going back centuries. But because the integration of systems visible in those photographs implies manufacturing philosophy, design thinking about production as a coordinated system rather than a collection of individual operations, that official history places in the early 20th century. Assembly line logic, workflow optimization, material handling systems designed to move product between production stages without manual transfer, quality control stations positioned at specific points in the production sequence, all visible in photographs from facilities that predate the management theorists who supposedly invented these concepts by half a century. The workers in those photographs complicate the story further. Look at them carefully. These are not unskilled laborers learning a new trade. The operational confidence visible in the body language, the way workers position themselves relative to machinery, the way they manage material at each station, shows expertise. Long-practiced, deeply internalized expertise. These people aren't operating in a new industry. They're operating in a mature industry whose origins predate the photographic record that supposedly captures its beginnings. The machinery itself, in cases where physical examples survive in museum collections and have been subjected to metallurgical analysis, shows material characteristics inconsistent with what we know about mid-19th century metal production. Alloy compositions requiring process control beyond what the documented smelting technology of the period should have permitted. Surface finishing to tolerances that imply machine tooling with dimensional accuracy were not supposed to achieve for another generation. The machinery that made the machinery. This is the manufacturing archaeologist's nightmare and the honest engineer's obsession, because sophisticated production machinery requires even more sophisticated machinery to produce it, which requires more sophisticated machinery to produce that. The regression must terminate somewhere in a foundational capability, a base level of precision manufacturing from which everything else was developed. We can't find that foundation in the documented record. What we find instead are the products of a mature manufacturing capability, appearing in the record already mature, already sophisticated, already scaled to industrial levels of output, with no visible developmental history. This is not how technology develops. This is how technology is deployed by people who already understand it. The commercial networks that move the output of these factories require their own accounting, because the commercial infrastructure of the 19th century is perhaps the clearest demonstration that something is missing from our understanding. Consider the problem of price discovery across oceanic distances before electronic communication. A merchant in Liverpool needs to know the price of cotton in New Orleans to make rational purchasing decisions. A commodity trader in Amsterdam needs to know the price of spice in Batavia. A grain factor in Odessa needs to know the price of wheat in London. These prices changed daily. They responded to weather, to political events, to shipping news, to production reports from agricultural regions. They required real-time or near-real-time information to be commercially useful. Without current pricing data, rational commodity trading at intercontinental scale is mathematically impossible. You cannot optimize a transaction when the key variable, the price at the other end, is months out of date. Yet the records show sophisticated intercontinental commodity trading, price arbitrage, hedging strategies, and coordinated supply management across oceanic distances throughout the mid-19th century. The trading houses that operated these strategies were profitable, consistently year-over-year profitable. In a rational market, persistent profitability in arbitrage trading requires better information than your competition. It requires prices that are more current, more accurate, more reliably updated than whatever system your competitors are using. These firms had better information. The trading records prove it, but the communication mechanism remains officially unexplained. The financial instruments that supported this trade are equally revealing. Bills of exchange honored across dozens of monetary standards by counterparties who had never met, enforced through legal mechanisms that operated across political jurisdictions with no formal treaty basis, insured by markets that accurately priced risks across oceanic shipping routes they could only understand through data we can't account for. The insurance pricing alone is extraordinary. Marine insurance rates in the 1850s and 1860s, when you examine the underwriting records, reflect accurate actuarial knowledge of maritime risk by route, by season, by vessel type. This actuarial accuracy requires loss data, systematic records of shipping losses, by route, by season, by vessel characteristic, over sufficient years to identify statistically significant patterns. The data collection and analysis system required to produce this knowledge was operating for decades before the insurance markets we're examining. It was operating somewhere. It was producing data that was being distributed to underwriters. We cannot find the system, we can only find its outputs. Now I want to talk about the buildings that everyone can see and almost nobody has examined honestly. The public structures of the 19th century, the administrative centers, the exchanges, the stations, the civic halls, the libraries, the educational institutions, represent an architectural achievement so uniform in its sophistication across so many different geographic and cultural contexts that the official explanation, convergent aesthetic preferences responding to classical models, fails on basic analytical grounds. You cannot explain identical structural solutions through shared aesthetic taste. Aesthetic preference might explain similar ornamental vocabularies. It does not explain identical load distribution calculations, producing identical structural geometries in buildings designed by people on different continents who never met and never corresponded. The acoustic engineering of these spaces is a particular focus of researchers who approach the evidence without ideological commitment to the official timeline. Concert halls and assembly rooms from the 1840s through 1870s demonstrate acoustic characteristics, reverberation time, frequency response, directional sound distribution, that acoustical engineers today identify as optimal for the space's evident purposes. Optimal, not approximately adequate. Not surprisingly good for primitive construction, measurably, professionally optimal. Acoustic optimization requires calculation. It requires understanding of how sound waves behave in enclosed spaces of specific geometries and specific surface compositions. It requires, in short, physical acoustics applied as a design discipline. Physical acoustics as a formal field of study was not supposed to exist in any systematic form until the last decade of the 19th century. The buildings predate the field that supposedly explains them. The only honest conclusion is that the field doesn't explain the buildings. The buildings represent knowledge that existed before the field, knowledge that was practical, applied, and evidently widespread enough to produce consistent results across many different construction projects in many different locations. Knowledge that was then formalized and codified in academic literature that we've mistaken for the origin of the knowledge, when in reality it was the documentation of something much older. There is a category of evidence I've saved for this point in the investigation because it requires the context of everything preceding it to be understood clearly. The energy systems. By the 1860s and 1870s, gas distribution networks in major cities were serving populations at a scale and with a reliability that required infrastructure investment, engineering knowledge, and operational expertise we cannot adequately explain. The networks extended for dozens of miles. They served thousands of connection points. They maintained consistent pressure through distribution systems that branched and merged with hydraulic complexity. They were metered, billed, and maintained through administrative systems, implying organizational capacity far beyond what individual municipal governments supposedly commanded. But it's what comes slightly later that forces the hardest questions. Electrical systems appear in the historical record already functional, already deployed, already scaled to serve districts and in some cases entire cities. We've been given a comfortable mythology about this: Edison and the Pearl Street Station in 1882, the great contest between AC and DC, the gradual extension of service outward from demonstration installations. This mythology is not false, but it is radically incomplete. What it omits is the evidence of electrical installations predating the official timeline. Lighting systems in buildings documented in photographs from the 1860s that show interior illumination inconsistent with gas fixtures of the period. Equipment in industrial facilities described in engineering surveys as electrical apparatus, at dates when electrical industrial equipment supposedly didn't exist in operational form. Patent filings describing electrical generation and distribution systems from inventors who worked in relative obscurity and whose work was never incorporated into the triumphalist narrative of electrical history. Who were these people? Where did they learn what they knew? Why does their work appear as isolated endpoints rather than as nodes in a visible developmental network? The honest answer. The answer that the physical evidence supports even when the documentary record is too sparse to confirm it explicitly is that they were not inventors. They were engineers. They were working with knowledge that existed, knowledge of electromagnetic phenomena and its practical applications, that was already understood, already developed to an operational level, already distributed through channels we cannot now clearly identify. The period we're examining wasn't discovering electricity, it was deploying it. The discovery happened somewhere else, in some other chapter of the story that we haven't been given access to. I want to dwell for a moment on the people, because it's easy, moving through evidence like this, to forget that what we're examining is not abstract historical data. It's the texture of daily life. It's what it felt like to wake up in a specific body, in a specific city, inside systems of extraordinary sophistication that were simply the background of existence. Not remarkable, not technological marvels, simply how things were. Imagine what that feels like from the inside. You don't marvel at the water pressure in your pipes. You don't marvel at the street lighting that illuminates your evening walk. You don't marvel at the coordinated transit that moves you from your district to the commercial center and back. These things are part of the fabric of ordinary life. You notice them only in their absence, the way we notice electrical power only when it fails. The people who lived inside these systems were not astonished by them. They were using them. They were as habituated to coordination and sophistication as we are habituated to our own technologies. They had expectations. They had standards. They had complaints when the systems fell short of those standards. And then, across a generation that seems to compress from this distance into a historical blur, the systems began to be dismantled. Not in an obvious way, not through dramatic destruction that anybody living through it would have recognized as loss, but through a series of replacements that each, individually, seemed like improvement and collectively represented the systematic degradation of a coherent system into incoherent fragments. Canal networks, elegant, integrated, self-sustaining, were replaced by railway lines that required constant external energy input, not because railways were better in every respect. In terms of cargo capacity per unit of infrastructure investment, canals were frequently superior, but railways were controllable in ways that canals, with their distributed ownership and decentralized management, were not. Building techniques that produce structures integrating multiple environmental functions, ventilation, lighting, acoustic management, thermal regulation, into single coherent architectural solutions were replaced by techniques that addressed each function separately, requiring multiple specialized systems to achieve what the older buildings had accomplished through geometry and material selection. Not because the new approach was more effective. Because it was more legible to people who had lost the conceptual framework necessary to understand integrated design. Water systems with biological filtration protocols that had, where implemented, virtually eliminated waterborne disease were replaced by systems with chemical treatment approaches that required ongoing industrial inputs. Not because chemistry was better than biology for water purification, because chemistry required a different kind of expertise to maintain expertise that could be credentialed, regulated, and controlled. The pattern of replacement is consistent. In every domain, integrated coherent systems were replaced by fragmented specialized solutions. Self-sustaining infrastructure was replaced by infrastructure dependent on external industrial supply chains. Distributed knowledge was replaced by credentialed expertise concentrated in institutions. Whatever happened, it served consolidation, and consolidation requires a story that justifies it. A story in which the old ways were primitive, inadequate, insufficient, ways that the progressive forces of modernity necessarily superseded. That story was constructed, and we've been living inside it ever since. The final piece of the evidence, the piece that I return to repeatedly, because it troubles me more than any other element of this investigation, is the problem of memory. Within a generation of the transition period, the knowledge was gone, not suppressed in some active conspiratorial sense, though there is evidence that specific archival materials were reclassified, relocated, or simply allowed to deteriorate without preservation, but gone in a subtler and more comprehensive way, gone from practice, gone from education, gone from the professional formation of engineers, architects, urban planners, administrators. You cannot teach what you no longer know, and the people who knew were agging, and their students were being trained in new paradigms that had no room for the old knowledge, and the institutions that carried the old knowledge were being absorbed into new institutional structures with different agendas. Within one generation, that's how long it takes. We know this from other knowledge losses. We know it from the history of traditional agricultural techniques, of indigenous medical knowledge, of craft traditions with centuries of accumulated optimization. One generation without transmission and the knowledge is gone, not hidden, not retrievable by future researchers who look in the right archives. Gone. What remains is the evidence in the physical world, the buildings that encode the knowledge in their proportions and their construction without explaining it, the infrastructure that embodies the understanding without documenting it, the systems that work according to principles that the people currently operating them no longer fully comprehend. We are those people. We maintain systems we don't fully understand, in buildings whose design logic we've stopped analyzing, through infrastructure whose engineering we've lost the conceptual vocabulary to describe accurately. We excavate basements and find apparatus we cannot identify. We demolish buildings and discover structural solutions we cannot reverse engineer cheaply enough to replicate. We survey old water systems and find gradient calculations more accurate than our survey instruments can confirm without advanced equipment. And we write reports that describe these findings as surprisingly sophisticated for the period, and file them in archives where they will not disturb the official account. This is where I've arrived after 3 years. Not at certainty, the evidence doesn't support certainty, and honesty requires acknowledging the limits of what can be demonstrated against what can only be inferred, but at a picture that is consistent, coherent, and deeply incompatible with the story we've inherited. A world existed. It was more organized than we've been told. It was more technically sophisticated than our timeline permits. It was more globally interconnected than our communication history explains. It ran on systems of energy, water, transit, commerce, and information distribution, whose operational principles we are still, in some cases, only beginning to reconstruct. The people who lived in that world moved through it daily with the comfortable familiarity of the habituated. They used the infrastructure without marveling at it. They worked within the systems without explaining them to each other. They lived in the buildings without analyzing their design logic. It was simply the world, simply what existed. And then it changed, gradually and then rapidly, completely and without adequate documentation of what was lost, replaced by something different, not worse in every dimension, but fundamentally less integrated, less self-sustaining, less coherent as a system, more dependent, more illegible to centralized control, more compatible with a narrative about progress that required the old world to be primitive. The photographs remain, the buildings remain, the infrastructure in fragments remains, the trade records, the engineering surveys, the construction permits, the municipal accounts, in archives that most historians never visit, examining periods that most academics consider too documentary sparse to be fruitful, the evidence remains. It doesn't prove Tartaria as a political entity with borders on a map. It proves something more fundamental and more unsettling. It proves that the story we've been given about the developmental trajectory of human civilization, the story of linear progress from primitive to sophisticated, from simple to complex, from local to global, that story is wrong. Not incomplete in minor details, wrong in its foundational premise, wrong in its assumption that what came before us was lesser, simpler, less capable. The evidence argues for a different premise, that there are things we've forgotten, that there are capabilities that were lost, that the trajectory of human knowledge and human organization is not a straight ascending line but something more complicated, with peaks and valleys, with accumulation and loss, with sophistication that existed and was surrendered, perhaps deliberately, perhaps by circumstance, but surrendered regardless. And that we have been, since that surrender, slowly building back toward an understanding that once existed and was set aside, reconstructing from fragments what was once whole, learning to see, in the buildings and the streets and the underground networks, the outline of a world that operated by principles we're only beginning to recover. The photograph is still on my wall above my desk, the street in Central Asia, the buildings with the impossible proportions, the geometry that shouldn't be there. I look at it every morning. It still asks the same question it asked the first time I couldn't scroll past it. What do you know that you've been taught not to see? The investigation continues. The archives are vast. The evidence accumulates faster than any single researcher can process. If this line of questioning matters to you, if the gaps in the official account seem worth examining seriously, then support this research. Subscribe, become a member. Share this with the people in your life who are still willing to ask uncomfortable questions. Because the answers are there, in the buildings that remember what the textbooks have forgotten, in the infrastructure that embodies knowledge we've been told never existed, in the photographs that preserve moments from a world that official history insists was too primitive to have left anything worth examining. It left everything worth examining. We just have to be willing to look.